right, so today we're going to be looking at trapezoids. We should be somewhat familiar with trapezoids. A trapezoid is a quadrilateral, so since it's a quadrilateral, we know a few things about it. Because it's a quadrilateral, we know it's flat, we know it's made with segments, we know it's closed. We know since it's a quadrilateral, it has 360 degrees in its four corners together, right? And it has four sides. So all of that we know not because it's a trapezoid, but because it's a quadrilateral, right? So I know four sides and 360 degrees because it's a quadrilateral. Now, because it's a trapezoid, we need to know what specifically makes it a trapezoid. And a trapezoid is a trapezoid because it has one pair of parallel sides. It can't have two pairs because if it has two pairs, then all of a sudden we're a parallelogram, right? So it only has one pair of parallel sides. It can't have two. My other two sides have to be not parallel. Okay, the other two sides have to be not parallel. The parallel sides have a specific name. The parallel sides are called bases. My parallel sides are called bases, and these are non-congruent. They cannot be the same. Okay, so however long one is, the other cannot be the same. But this is a base here, and this is a base here. My parallel sides are called bases, and they cannot be congruent to each other. Because if they're parallel and congruent, that's enough to prove if one side is parallel and congruent, that's enough to say we have a parallelogram. So they have to be non-congruent. Okay? Then the next thing we need to know about the trapezoid is my non-parallel sides. They also have a name. They are called the legs. So this is a leg, and this is a leg. Okay? They can be, but they don't have to be, congruent. They can be, but they don't have to be congruent. They can be, but they don't have to be congruent. Okay? So for example, if you look at the example there, this one, if this is to scale, this one looks like it's probably going to be longer than this one. Again, we don't know if that's true because we don't know if it's to scale. Okay? Leg angles are always, any idea about leg angles? So like that means angles on the same leg, so like this angle and this angle. Supplementary. Anybody know why they would have to be supplementary? Not because they form a line, because they're not adjacent, and only a linear pair would form a line. Those aren't really a linear pair. Not necessarily. No, not because there's 360 degrees, because then that would be true for all quadrilaterals, not true for all quadrilaterals. It has something to do with if I were to think of this leg as part of a line, and if I were to think of this base as part of a line, and this base as part of a line. They're consecutive interior angles between parallel lines, right? So, and we know if you have parallel lines, your consecutive interior angles are going to be supplementary. And that's going to be true on both sides. So it'll be true on the left side. It will also be true on the right side. Your angles don't have to be the same, though, on the left and the right. Okay? So if I were to think of this is angle A, and this is angle B, I know A plus B has to equal 180. And if this is angle C, and if this is angle D, I know C plus D has to equal 180. But A, B, C, and D, none of them have to equal each other. All four angles can be different. All the angles can be different. Okay? None of the angles have to equal each other. That doesn't mean they don't ever equal each other. Sometimes they do. But they don't have to. They can all four be different. But A and B, the ones on the same side of the same leg, will be supplementary, and C and D, the ones on the same side of the other leg, will be supplementary. Okay? All right. Next thing we need to know about a trapezoid is that it will contain, or can contain, what's called a midsegment. And a midsegment, just like a midsegment in a triangle, it connects the two midpoints of the legs. Okay? Connects the midpoints of the legs. There are two properties. The first one is it is parallel to each base. So if this is a trapezoid, all three of these little segments would be parallel to each other. And then the second property that it has is it is the average of the bases. So if I knew how long one base was, and I knew how long the other base was, then I could find the midsegment by averaging the two bases together. So my midsegment would equal, to average two things together, if I want to average base 1 and base 2, I would take base 1 plus base 2. And since there's two things I'm averaging, I would divide it by 2. That's going to find my midsegment. So your midsegment will be parallel, which also kind of means you'll have a lot of corresponding angles, right? If they're parallel, I know this angle here is going to have to be congruent to that one there. And then this one here has to be congruent to the one on top. And then same thing on the other side, right? Because you'll have corresponding angles with parallel lines. Corresponding angles are always congruent. Okay? All right, my first example says to find EF. So EF is the midsegment. We know the midsegment is the average of the two bases. So the distance from E to F, the midsegment, will be the average of the two bases. One base is 13.5. The other base is 8. Find its average. Add them together, divide them by 2. 13.5 plus 8? 21.5. Divided by 2? 10.75. Units. Just regular old units because it's a length, not an area. Find LP. So this one's a little bit different because on the last one they wanted me to find the midsegment, which was pretty simple because you just average the other two together. But this one wants you to kind of work backwards and find one of the bases when you're given the midsegment. We know that the midsegment, which is 23, would equal the average of LP and NS. So LP plus NS, which is 28, divided by 2, would give me 23. Yes?
Multiply 23 by 2 and then subtract 28.
Yeah, just work backwards. Multiply both sides by 2 to get rid of that there. And so then 2 times 23 is 46. So LP plus 28. Subtract 28 on both sides. So 46 minus 28 is how much? 18? Here's kind of a cheater way to do it. I would never tell you to cheat, but here's kind of like if you were just missing one of the ends. It doesn't work as well to use this method. This method would work to check the midsegment you found over here. But to kind of, as a way to kind of cheat this one, really the 23 is right in the middle. It's the average, which means it's the number exactly in the middle. So if I go, oh, between 23 and 28, it's a change of 5, right? From 28, I go down 5 to get to 23. So just go down 5 more to get to 18. So that's a way you can do it without having to do the whole formula. Kind of just a little time saver there. Okay? Just as a little side help. All right, so everything we just talked about is true for every single trapezoid, no matter what. Now we're going to talk about a specific type of trapezoid, and that's an isosceles trapezoid. And if we talk about an isosceles triangle, that means it has what? Isosceles triangle. Two sides that are equal. Okay? Well, in a trapezoid, I can't have two bases that are equal because then I'd have a parallelogram, right? So we can't have two opposite sides that are equal. In an isosceles trapezoid, it has to be the legs that are equal or congruent. Okay? So an isosceles trapezoid is just a trapezoid where your two legs are equal. This is the kind of trapezoid you see when you're first learning trapezoids. They only ever show you isosceles trapezoids. Okay? There are two properties that you need to know about your isosceles trapezoid other than the fact that your angles or that your legs are the same. That's important to know. The first thing is that both pairs of base angles are congruent. Okay? Both pairs of base angles are congruent. So remember before when I labeled A, B, C, D? And I said here's A, here's B, here's C, and here's D. And I said they don't have to equal each other. Well, in this case, the ones that are on the same base will equal each other. So B will equal C, and A will equal D. That doesn't happen in every trapezoid. That only happens in isosceles trapezoids. Now, A plus B still has to equal 180, the two on this leg, and D plus C still has to equal 180 because it's still trapezoid. Okay? All right, the second thing that we need to know is that our diagonals are also congruent. Our diagonals are also congruent. So that means this diagonal is the same length as this diagonal. Which was also true for rectangles. The only difference is in a rectangle they're bisected, and here they are clearly not bisected. Okay? So on this one, if I were to label my corners as A, B, C, and D, the distance from A to C would equal the distance from D to B. Okay. Also, they're divided kind of proportionally, not a specific ratio, but you'll also find if you were to put a letter in here, let's say E, we would find that A to E is equal to D to E, and B to E will be equal to C to E. Which tells me I'm going to end up with isosceles triangles coming from each base. If this piece here is the same as this piece here, this piece is the same as this piece, and then the whole diagonals are equal to each other. And then, since my base angles are equal, they're divided equally here too. So these two inside angles are equal to each other, and then these two on the other side of the diagonals are equal to each other. And then the same thing up here. These two are equal to each other, and these two are equal to each other. Lots of equal things in an isosceles trapezoid. All right, so find each angle. Okay. First thing it's helpful to do is make sure you know where your legs are and where your parallel sides are. So these are my parallel sides. Because it's a trapezoid, I know both the angles on the same leg have to be supplementary. So if the angle up here is 50, what does the angle underneath it have to be? 130. And then because it's isosceles, these tick marks here show me that it's isosceles, these two angles have to match these two angles on the same base. So 50 along this base and 130 along this base. Okay. On the next one, sometimes your trapezoids aren't sitting all nice and pretty. This one's kind of rotated. It like fell over. That's why it's always kind of helpful to just kind of visually eyeball where your parallel sides are. How big is angle J? J? 118. They're on the same parallel sides. K and J are the same. How big is angle L? 62. And angle M? 62. Easy peasy. All right. How big is angle X? 28. That one's so easy, people get it wrong. There's one like that on your test. Don't get it wrong. It's so easy. All you have to do is look at it, and if you're not sure, if you guess, you'll probably guess right. But people still get it wrong all the time. The next one is a little bit more challenging. The next one, find X. Spoiler alert, it's not 15. Yes, so X is 28 because, remember my diagonal, this whole angle is the same, this whole angle is the same. These diagonals are divided into two congruent pieces down here and two congruent pieces up here. So this makes an isosceles triangle, and so my base angles have to equal each other. Okay? Same thing over here, these two angles have to equal each other, right? So I know this angle is 40. Any ideas where to go from there?
Could you add 40 and 15?
You could add the 40 and the 15. That would give you that whole angle. That whole angle here is 55. Subtract that from 180. That would give me, that's not X. That would be this whole angle is 125. The angle's not bisected, so I can't divide it in half. How do I figure out what just X is? There's two different ways from what we've done so far that I could figure it out. Two different methods. I can either use triangles, or I can what I know about triangles, or I can use what I know about parallel lines. Yes?
If the bottom of triangle that being isosceles, so then you'd add the two to 80, so 180 minus 80 gives you 100, and the vertical angle.
Wait, which ones am I adding together? These two? So 40 and 40 is 80.
Yeah.
So that means this angle here is 100. Okay? It's a vertical angle. Yep.
And those are isosceles, which is 80 plus 40, 40, 125 minus 40.
So if this is 100, that means there's 80 left. Is that what you said?
Yeah. And they're isosceles, you just split them.
And 40, 40? And then what?
You subtract 125 minus 40.
Subtract 125 minus 40. And I get 85 for X. That is a way to do it. I probably, if it was me, I probably would have thought about this triangle right here. Again, more than one way to do it. and I would have said, oh, the lower left corner is 55, the lower right corner is 40. So in that triangle, I've used 95. 95 from 180, x is 85. But again, the way we did it worked also, right? There's more than one way to do it. I said we could either do it with the triangle or we could do it with parallel lines. I would have said another way, we could have said this line and this line are parallel, so my alternate interior angles are the same. So if this one's 40, this one's 40, and then we had already found that that one was 125. Okay? So again, lots of ways to do it. Another way, once we found this 100 here, we could have said that means this angle here is 80, and we could have used the 80, the 15, and the x to figure out that we had 85 left. Okay? So as long as you're using sound properties, there's lots of different ways to find x in this particular problem. Some of them have more steps than others, and that's okay. All right, the next one, KB is 21.9. So KB is just this little bit here, is 21.9. And FM is 32.7. Find FB. Any ideas? Yes.
KB and MB are congruent.
Uh-huh.
So BM equals 21.9 and subtract 21.9 from 32.7.
Yeah. If this one's 21.9, then that means this one over here is also 21.9. So then I just have to take that away from the 32.7 to figure out what's left for FB. So the orange, the 32.7, minus the blue, 21.9, will give me the green part that's left of that whole orange segment. $10.8. Did I do my math right? Questions? All right. Next, we're going to look at area of a trapezoid. So the area of a trapezoid is going to be similar to a parallelogram, but since my bases are different, we just average the bases together. So it's still base times height, but we have two bases. So instead of doing just base times height, it's the average of the bases times the height. So sometimes you'll see the formula written like this. Sometimes you'll see the formula written like this, 1/2 base 1 plus base 2 times h. Sometimes I've even on occasion seen it written as area equals base 1 plus base 2 times height all divided by 2. All of those will do the exact same thing. Because multiplication is commutative, it doesn't matter where you do that divide by 2 or that multiply by 1/2. Okay? Remember, it is super important that you remember that your height is always going to be perpendicular to the base. Okay? Perpendicular to the bases. You have two bases, it's got to be perpendicular to both of them. If it's perpendicular to one, it's going to have to be perpendicular to the other because they're parallel. Alright, so first one's pretty simple. Area equals 1/2. What are my two bases? 18 and 40. And then what's my height? 15. So then my area equals 1/2 of 58 times 15. That one my brain is like, no, I don't feel like doing that one without a calculator. Don't save whatever they were doing before because I don't trust them. 18 plus 40 is 58. So I already did that. 1/2 times 58 times 15 is 435. And these are meters, and it's area because I've got 58 meters times 15 meters, so meters times meters is meters squared. Okay. The next one area equals 1/2. What are my two bases? 32 and 18. Oops, 32 plus 18, not times 18. That will give us a real different answer. And then what's my height? 16. And you don't have to pause in the middle to add those two. You could just put it all in your calculator at one time. You can do 1 divided by 2 times parentheses 32 plus 18 parentheses 16. So I put the whole thing in the calculator exactly as it is. And I get 400. Feet times feet is feet squared, or square feet. 400 square feet. All right. And then the last one on this row, area equals 1/2. What are my two bases? 12 and 24. It's okay that it's sideways. What's my height? 28. So my area equals, I'm going to put all that in my calculator at the same time. 1 divided by 2 times parentheses 12 plus 24 parentheses parentheses 28 gives me 504 yards squared. Questions? Nope, we're good. Okay. Ryan runs a landscaping business. A new customer has a trapezoidal shaped backyard shown at the right. How many square feet of grass will Ryan have to mow? If Ryan charges $5 for 100 square feet, how much should he charge the new customer? Alright, so we're going to need to find the area. Area equals 1/2. What's one of my bases? What's this top base? 20.5. Plus, what's the bottom base? 30.5. What's the height? 38 point what? 25. So that, I can just put that in the calculator. 1 divided by 2, parentheses 20.5 plus 30.5, parentheses, parentheses, 38.25, gives me 975.375. Square feet. If he charges $5 for 100 square feet, how much should he charge the new customer? How do I figure that one out? Divide by what? By 5? By 100. 975.375 divided by 100 is going to give me, we just moved the decimal over 2 places, right? 9.754. So that's how many 100 square feet there are. What do I do with that? That I multiply by 5. So I end up with times 5. I should charge $48.77. If I was Ryan, I would just say, I'll do it for $50. Oops. That's just me. Because I don't want to deal with change, right? So that's what I would do. Questions? All right, one more. This last one. Isosceles trapezoid, so I know it's got legs that are the same, base angles that are the same, diagonals that are the same. Trapezoid RAMS with bases RA and MS has the following coordinates. Find the coordinates of point S and the area of the trapezoid. All right, so let's plot those points that we know. R is at -3, -3. A is at -3, 5. M is at 3, 8. So here's R, here's A, here's M. We know that we have to walk around our shape so we don't fall in the hot lava. We've talked about that lots and lots, so we know that has to be true. So when I connect, I have to connect in the order R, A, M, S. So I have to connect from R to A, and then A to M, and then I'll have to put S somewhere so it'll connect, and it makes a trapezoid. Where my bases are RA, which is vertical, and MS. So that means MS has to be somewhere along, S is going to have to be somewhere along this vertical line. I just need to figure out exactly what, I could put it anywhere on that line, and as long as it didn't make parallel with AM, anywhere I put it on this line except for that one point where it would be parallel, anywhere would be a trapezoid, right? But I want it to be an isosceles trapezoid, so that means it needs to have the same length as AM. It needs to have the same length as AM. Okay? I know it has to be somewhere along that vertical line so that the two sides are parallel. The two bases, RA and MS, are bases. Okay? So now I just need to figure out how to know where that needs to be. Any ideas? From A to M? My slope from A to M is I have to rise 1, 2, 3, and over 1, 2, 3, 4, 5, 6. So my slope from A to M, I went up 1, 2, 3, 1, 2, 3, 4, 5, 6. So 1 over 2. Okay? So I do I don't do the reciprocal slope, just the opposite slope. So instead of going up 1 over 2, because if I go up 1 over 2, I'll be parallel and I'll make a parallelogram. But if I, instead of going the same direction, I go down instead of up, down 1 over 2, down 1 over 2, down 1 over 2, then I should end up where this is going to have the same length as that. They both kind of flare out the same amount, right? They have to have the same angle with RA. So S is going to be right here, which is going to be the point 3, -6. 3, -6. I'm not done though, because what else does it tell me I need to do? Find the area. So to find the area, we do 1/2 base 1 plus base 2 times the height. So my area is going to be 1/2. How far is it from R to A? 8 plus, how far is it from M to S? 14. And then what's the height? So if my bases are vertical, then perpendicular to that would be horizontal, right? So I just have to draw in a horizontal height. And then just see what my distance is. What is it? 6. So 1/2 of 18 plus 14 times 6. Gives me 96. Square units. Because it's area. What did I do wrong? Oh, I put 18. 66. Any questions on trapezoids? All right. In your journal, the only thing we have left is there is a review. And then after the review, there are some practice problems for like a practice assessment that you can, once you get the answers to, you can, if you do the quadrilateral assessment questions, it'll kind of give you an idea if you were to take the test, what you'd get on it if you just took it without studying. And it'll give you an idea of the type of things you need to know to study. Does that make sense? Okay. All right, so you do have an assignment on trapezoids that is available to you in Schoology.